Hi everyone. So we are finishing up with minerals and we are now going to be getting into rocks. And it's important to start with minerals because minerals make up a large part of rocks. So the definition of rocks. Rocks are a naturally occurring solid mixture of one or more minerals or organic matter. And you remember the difference between organic and inorganic. Organic means living or once living, and inorganic means not living. So the processes that shape the earth and in turn, of course, shape rocks, whether it's destroying rocks or creating new rocks, there are a couple different processes you need to learn about. The first is weathering. Weathering is when water, wind, ice, and heat break down rock. It is important that you understand the difference between weathering and erosion, and that you realize that weathering is the breaking down of rock. Erosion, on the other hand, is the process where sediment is moved from one place to another. So weathering is breaking down, erosion is moving something from one place to another. And you can have weathering and erosion happening simultaneously, which means at the same time. Deposition. Deposition is when you have sediment that is moved by erosion, it's dropped, and then it comes to rest somewhere. Think of the word deposit, which is in the word deposition. If any of you have a checking account or a savings account, when you want to put money into it, you are depositing into that. Also, heat and pressure are another process that can change rock. If you have enough heat and enough pressure, you can actually change a rock from one to a totally new type of rock. Now, I kind of skipped rock cycle, and we will be getting into the rock cycle, and you will be watching another video on rock cycles, but I do want you to know the definition, and that the rock cycle is the continual process where new rock forms from old rock. Okay, that's all you need to know about the rock cycle right now. All right, so we have three main types of rocks that we're going to be talking about, and the first is igneous. And igneous in Latin means fire. And it's important to remember that word fire because it will help you remember that igneous begins as magma, okay, magma coming from volcanic activity. And that magma cools and solidifies and turns into a type of igneous rock. Now, igneous rock its identification is based on its composition and how the particles form. So we're going to start with composition. And composition describes the minerals or other materials in the rock. Okay? And the first type that we're going to talk about is felsic. Okay? Felsic rock is very high in silicon, and it has a very low density, and it's usually a very light color. Okay? An example of a felsic rock would be granite. So just remember, felsic is a very light color, usually. Mafic, on the other hand, usually has a less of a silicon amount. It has a higher density, and it's usually a very dark color. Okay, for example, gabbro, which is what is pictured in this lesson, and there's also basalt, which is another type of igneous rock. Next, we move on to texture. Okay, texture is how smooth or rough something feels. A coarse textured igneous rock usually has very large crystals, and remember, the more coarse an igneous rock is, the more slowly it was cooling. It took more time for the crystals to grow. There's also fine-grained rocks. And those are rocks that cool fast. So they have smaller grains within them, so they're usually a little smoother. Okay, now we have the formation of igneous rocks, and they form usually above or close to the surface of the crust or below the surface of the crust. So if it's an intrusive igneous rock, this type of igneous rock forms below the surface. And because it's deep below the surface, it cools very slowly. And because it cools slowly, it has a coarser texture to it. Just remember, intrusive in the earth. Extrusive igneous rock, on the other hand, form near the surface or on the surface of the earth. Because they're so close to the surface or on the surface, they cool very quickly. So they have a much smoother texture. Okay, now we are going to be moving on to sedimentary rocks. And when you think of sedimentary rocks, when you think of layers, okay, sedimentary rocks are formed by deposition, which is a word you just learned, and that's the accumulation and the settling of sediment, okay? And that happens because of weathering and erosion, and then rocks piling up on top of one another. Okay, and because of this, they are compact, and compaction begins. The dissolved minerals create like a cement. If you notice the rock, the sedimentary rock below, how it has the layers of different sediment and minerals within it. Okay, the composition, the makeup of sedimentary rocks are broken down into three different distinct sections. There are clastic rocks. These are made from fragments of other rocks that are cemented together and can be coarse, medium, or fine-grained. Okay, the picture next to this shows a rock that it's a conglomerate that has a lot of big chunks of other rocks in it. Next is chemical formation. This is formed from solutions of dissolved minerals and water. And then finally we have organic, which, don't forget, organic means living or once living, and it's the remains of plants and animals or fossils of animals. And examples of that are limestone and coal. Okay, the structure of sedimentary rocks is based on a process of the layering of the rocks. And this structure can help record the motion of wind and water, from the past. So remember that stratification is that process of layering of rocks. All right, next we get into metamorphic rocks. And for metamorphic rocks, I want you to remember the word change or metamorphosis. Remember, metamorphism deals with anything that changes from one thing to something totally different. So, for example, caterpillars change into butterflies. They go through a process of metamorphism. So, change or metamorphosis does not occur unless there's an incredible amount of heat and pressure. And because of this incredible amount of heat and pressure, rocks will literally change totally and completely into something else, whereas a sedimentary rock can have other rocks within it, but it's not changing into a total new type of rock. So if you look below here, we have shale, which is a type of rock that with enough heat and pressure turns into slate, and with more heat and pressure may turn into phyllite, onto schist, and gneiss. Metamorphic rocks can also have different textures to it. Foliated metamorphic rocks are mineral grains that are arranged in bands. You can see the lines that kind of go through this. And then non-foliated, which are minerals that are obviously not arranged in bands. And then lastly, we have the structure of a metamorphic rock. And I just want you to remember the word deformation. And this is the change in the shape of a rock caused by forces. This can cause rocks to be squeezed or stretched. If you notice the lines, the stratification going through here shows that there was some squeezing of the rock and caused it to be deformed. Okay guys, so this is it with the rock presentation. We'll obviously be practicing with this, and you will be learning about the rock cycle, and you will be also doing some labs with rocks. So if you have any questions, try going back through this presentation again, or you can come and see me and we will talk about it. So you guys have a good night, and we'll see you tomorrow.